Hello dear students, in this video we are going to learn how to solve differential equation of first order and of first degree using variable separable method. So let us start with this kids. We'll understand first the meaning of what is differential equation, what is first order and what is first degree of differential equation. Now what is a differential equation? Any equation in which derivative is present is called as differential equation. Very simple and keep it simple. So, for example, like this. So, in this equation, you can clearly see there is a derivative dy by dx present in the equation. Therefore, such equation is called as differential equation. Is it necessary that we can have only dy by dx? No. You can have a derivatives like this also. D square by dx square plus y d by dx minus sin x is equals to 0. So in this, you all can see we are having differential equation in which second order derivative is present. So any equation in which derivatives terms are there, then that equation becomes the differential equation. Now let us proceed ahead and understand what do we mean by differential equation of first order and first degree. Now, for example, if I consider this first equation, in this equation you can see the derivative, the highest derivative is present in this differential equation is what? Dy by dx. That is first order derivative. So, order of this differential equation is going to be 1. Where in the second example, the highest order derivative present in this equation is d square by dx square. Therefore, the order is going to be 2. So, the order of the differential equation is the highest order derivative present in the differential equation, then that would be the order of my given differential equation. Now, what is degree then? Degree is the power of the highest order derivative. Now, in this first example, the degree or the power of dy by dx is 1. Therefore, degree is going to be 1. We look at the highest order derivative present in the differential equation and its power is going to be its degree of the differential equation. Where in the second example, we can see the highest order derivative is d square by dx square and its power is 1. Therefore, the degree of the given differential equation is going to be 1. Then, what will be the order and degree of this differential equation? Equals to cos x. So, in this, you all can see the highest order derivative present in this given differential equation is 3. Therefore, the order is going to be 3. And we are going to look at the power of the highest order derivative. In this, the highest order derivative is this and its power is 3. Therefore, the degree of this differential equation is going to be 3. I hope how to identify the order and the degree of the given differential equation is clear to everyone. Now let us proceed ahead and understand what do we mean by the solution of differential equation. Now students, we all know that a differential equation is an equation in which derivatives are present or you can see the coefficients are what? Differential derivatives. Now solving differential equation means we have to get that equation for y which are going to satisfy my given differential equation. For example, suppose I am having dy by dx equals to cos x. So this is my differential equation. What do I mean by solution of this differential equation? So I have to get the original equation of which the derivative is this. So that what could have been that equation of which the derivative is this, dy by dx equals to cos x. So from this we can clearly say because it's very easy of which function the derivative is what? Cos x. We all know that it is sin x plus c. So we all know that if I take its derivative, so it is going to be dy by dx and derivative of sin x is going to be cos x and the derivative constant is what? 0. So again, so we have to get this equation and you'll be given this differential equation. So from the given differential equation, you have to solve this differential equation to get this equation. So you have to get the equation for y, or you can say I have to get the original equation of which the derivative is the given differential equation, or you can say I have to get that equation in which derivative is absent. Okay, the final answer when you after solving the differential equation, the final answer should not contain any derivative present in it. So it should be without, it should be free of derivatives. So such equation you have to find such equation. When you find such equation, that is the meaning of the solution of the differential equation. So I hope I have made my point very clear to everyone. Like what is differential equation? It is an equation in which the derivative, the coefficients are derivative. What is the order of my differential equation? The highest order derivative present in the differential equation is called as the order of the given differential equation. What is the degree of the differential equation? It is the power of the highest order derivative present in the differential equation. And next we understood what do we mean by solution of differential equation. So solving differential equation means I have to get that original equation, or my final answer should be free of derivatives. So that's the meaning of solving differential equation. So there are various methods of solving a differential equation, kids. Okay, and we are starting with the first method for solving the differential equation, that is the separation of variables. So that is our first method to solve the differential equation, and we are going to see all the methods of solving the differential equation one by one. And this video will be covering only the separation of variable method for solving differential equation. So our first method, separation of variables. So let us understand how separation of variable method is going to help us to get the solution of my differential equation. Okay, before that, I would like to tell you all that the standard form or standard way of writing my given differential equation is this: dy by dx is equals to f of x comma y. What do we mean by that? In the given differential equation, we are going to keep dy by dx on one side, and we are going to take all the term on the other side, and that term we are denoting by f of x comma y. So there is a standard way of writing a differential equation, which is dy by dx equals to f of x comma y, where f of x comma y is a function of variables x and y. Now, when you can think of applying variable separable method, when when it is possible for you to separate variable y on one side and the variable x on the other side. When it is possible for you, when you can separate variables very easily, then you will think of this method, which is variable separable method. So which means dy by dx, this f of x comma y can be written in this f of x f1 x comma y upon f2 x. Sorry, if I'll be able to separate variables like this, f1x upon f2y. So where f1x is a function of x only and f2y is a function of y only. That means I have separated variables. I have separated the equations which are having only x in it, and I have separated equations which are having only y in it. So if that separation is possible, then you are going to think of this variable separable method. Now you have to keep all the y term on one side and all the x term on the other side. So this f2y, which is a function of y only, that I'm going to take off left hand side. So it will become f2y and dy as it is. And f1x, and this dx will go on right hand side and it will become f1x dx. Please remember that this dy and dx should be present in the numerator only. You shouldn't be writing this way, 1 upon dx. No, you don't have to write this way. So remember that dx should be in the numerator. Why? Because the next thing we are going to integrate them. Okay, so on integration, so because of that reason, you have to keep dx on dx in numerator, so that you can integrate it with respect to the corresponding respective variables. Okay, so this here you can see I have separated variables y on one side and x on the other side. Now next step I have to eliminate this derivative. So how can I eliminate those derivatives? We all know that the integration is antiderivative, right? So if I take integration of derivative, I'll be left with my equations. Okay, so the both the sides I'm going to integrate it. So here I'm integrating with respect to variable y, and on right hand side I'm going to integrate it with respect to variable x. And then you're going to integrate it, and then derivative will be removed, and you will be left with your solution of your differential equation. So it's very easy variable separable method. You just have to separate variables. You have to keep one variable on one side and on the other variable on the other side. Make sure that you are writing dy and dx in the numerator. It should not be in the, it should not present in the denominator, because in next step we are going to integrate it, and the with respect to that variable, that dy and dx are going to decide with respect to which variable we have to integrate it. Okay, so let us understand this with an example. Question number 1. Solve dy by dx is equals to xy plus x plus y plus 1. So let us solve the let us solve this question. Very easy, kids. Yeah, we are just trying, we will just try to separate the variables. We will try to keep y on one side and x on the other side. Let us do that if it is possible for this particular differential equation. So I'm keeping dy by dx on one side. I can observe that from the first two terms I can take out x common. So I'll be left with y plus 1 inside the bracket. And in the third and fourth term, I can see here there's only one term common, that is 1, and y plus 1. So y plus 1 is common in both the terms, that I'm going to take it out, and you'll be left with x plus 1 in one bracket and y plus 1 on the other bracket. And in left hand side, we are having dy by dx. Now still my variables have not got separated. I have to take this y plus 1 on left hand side and dx on the right hand side. So next step I will get 1 upon y plus 1 dy is equals to integration of x plus 1 dx. Let us integrate it. Now, okay, I have not applied the integration thing. So I have just separated variables now, x plus 1. Now, we will be taking integration on both the sides. So I will get integration of 1 upon y plus 1 dy is equals to integration of x plus 1 dx. Now let us integrate it. So integration of 1 upon y plus 1 is log of y plus 1. And integration of, there are two terms, so we are going to integrate it individually with respect to x. So integration of x with respect to x is going to be x square upon 2 plus integration of 1 with respect to x is going to be x plus integration constant. So you all can see you have got the final answer, which is which is free of derivatives. So such equation you have to find out. That is the meaning of the solving differential equation. That was the first question. Let us understand. Let us go to the second question. Question number 2. Solve 3 e raised to x tan y dx plus 1 minus e raised to x sec square y dy equals to 0. Okay. So again we are going to use variable separable method to solve them. So let us do that. So first of all, I'll try to separate the variables. I'll try to keep x on one side and I will take y on the other side. So let us do that. So from the given differential equation, I'll try to keep dx, all the terms containing x on left hand side and all the terms containing y on the right hand side. So here what I will get, 3 times e raised to x tan y dx, and I'm taking the second term on the other side, then it will become minus 1 minus e raised to x sec square y dy. Now still my terms have not got separated, so I have to take this tan y on the right hand side and this 1 minus e raised to x on the left hand side. So I will get 3 e raised to x minus 1 upon e raised to x, because since here it is multiplied, so it will come over here and it will get divided dx and sec square y upon tan y. So yes, your terms have not got separated. Now you have to take integration on both the sides. So I will get integration of, I can see 3 is constant, that I can keep it outside, and I'm taking this minus e raised to x in the numerator, this minus sign I'm talking about. So this minus I'm taking with e raised to x upon 1 minus e raised to x dx. So this is my left hand side. The right hand side is going to be sec square y upon tan y dy. We all know that one of the property of that integration is that when we are having functions inside the integration like this, f dash of integration of f dash of x upon f of x, that means that derivative of numerator is present in numerator, derivative of denominator is present in numerator, then you can think of the applying this property. which says integration of f dash of x upon f of x is going to be log of f of x plus c. So this is the property of the integration, which says if the denominator's derivative is present in numerator, then you can think of this applying this property, and which is the from this property you will get the answer as log of f of x plus c. So let us apply this property in the above equation number star. So I can see if I take its derivative, let me choose another color. If I take its derivative, so once derivative is 0, minus as it is e raised to x, derivative is going to be e raised to x. So I can see the final answer is going to be minus e raised to x, and it is present in the numerator. So it is of the form f dash of x upon f of x. Similarly, on the right hand side, we know that the derivative of tan y is what? Sec square y, and it is present in the numerator. So yes, we are on both the sides we can apply this property. So from the by applying this property, we'll get the answer as 3 times log of 1 minus e raised to x. Please understand, you have to write the log of f of x, not f dash of x. So what was your f of x in this? It was 1 minus e raised to x. So that I wrote over here is equals to log of tan y plus integration constant. Also I'm going to take it in log because all the terms are in log. So integration constant also I'm taking in log. Okay, now let us simplify it a little, and then you will get the answer. 1 minus e raised to. Now I am applying the property of log. So a log b is going to be log b to the power a is equals to log of, sorry, a is going to be 3 is equals to log of tan y plus log c. Okay, now what you have to do, kids, we all know the property of log a plus b, right? So log of a plus b is going to be log a into b. So I am writing here log of tan y times c. So log of a plus log of b is going to be log a times b. Now I can see left hand side, right hand side, both the log terms are there. Now I will take anti-log on both the sides. Please remember that you're not going to cancel logs, you're going to take the anti-log on both the sides. Okay. So when you will take anti-log on both the sides, you'll be left with 1 minus e raised to x the whole raised to 3 is equals to tan y dot c. So this is your final answer, case, which is the general solution of your given differential equation. So I hope I have made this problem very clear to everyone. Let us go to the last question on variable separable method. Question number 3. Solve dy by dx is equals to x square root of 25 minus x square. So let us see that how can I apply variable separable on such problem. So as we all know, we are going to keep dy on one side, and I am going to take this dx on the other side. So I will be left with this. So आप देख you can clearly see that we have separated the variables y on one side and x on the other side. Now let us take the integration on both the sides. So your integration of 1 dy is equals to integration of x square root of 25 minus x square dx. Now integration of 1 with respect to y is very easy. Now what about right hand side? Which formula is applicable to this such functions? Okay. So I don't think so any standard formula we have for such type of function. So what am I going to do? I am going to take the substitution. So I am taking the substitution over here as put 25 minus x square as t. Now differentiate it with respect to x. So your next step is going to be derivative of 25 with respect to x is going to be 0 minus derivative of x square with respect to x is going to be 2x is equals to derivative of t with respect to x is going to be dt by dx. So what I'm going to do, I'll see the integration terms. So I can take x and dx together, and you will get x. If I'll take x and dx together, then I'll get minus dt upon 2. Now all these substitution I'm going to put it in star. So from star, what I will get, kids? So from star I'll be getting integration of 1 dy is equals to integration of, now under root. So under root 25 minus x square I have taken as t, so that I am writing over here, and x dx will become minus dt by 2. Now the calculation will become very easy now. Now integration of 1 with respect to y is going to be y. Here I can see minus half is constant. I can take it outside, and integration of t raised to half. We are going to integrate, and minus half. Integration of t raised to half is going to be t raised to 3 by 2 upon 3 by 2 plus c, integration constant, and in left hand side we are having y. Now which term is getting cancelled out? This 2 and 2 will get cancelled, and you will be left with y equals to minus 1 upon 3 t. Now t raised to 3 by 2 plus c. What was the, now d substitute in place of t? So we had taken t as 25 minus x square. So that I am substituting over here plus c. So this is your final answer here. Okay, so that's it. Problems on variable separable method. Now I'm giving you all question for exercise. Just try to do on your own and see whether you're able to separate the variables and whether you're able to integrate them or not. So here your question: x square minus yx square dy plus y square plus xy square dx equals to 0. So just try to solve on your own, and you'll be done with variable separable method. I hope you have understood today's method for solving differential equation. Thank you.